Hey folks, ever felt lost trying to decode those cryptic electronics datasheets? Today, I'm going to unlock the secrets of electronics datasheets and make you a pro at understanding them. First things first, what is a datasheet? Simply put, it's a document that provides all the information you need about an electronic component, from electrical characteristics to mechanical dimensions. It's your go-to manual for using that component effectively. Now let's dive into the basics. Start with This typically includes the component's name, part number, and a brief description. It's like the cover of a book, giving you a snapshot of what's inside. Next up, This section shows you the layout of the pins and their functions, crucial for making sure you connect everything correctly. Then there's This is vital. It tells you the limits you shouldn't exceed, like maximum voltage and current. Think of it as the component's red line. Moving on to Here you'll find all the essential specs like operating voltage, current, and power consumption. It's the heart of the datasheet, telling you how the component behaves under various conditions.
Since we are discussing about datasheets, here are the few crucial points to focus on before designing. If you want to start any design, you please focus on the datasheet first. It should be done by all the engineers or the technicians who are into manufacturing and service industry. So points are absolute maximum rating. First point is absolute maximum rating. Why important? Because it defines the maximum voltage, current, and temperature limits beyond which the components may get permanently damaged. So data sheet will give you the complete idea about voltage, current, and temperature, the maximum one. Second point is electrical characteristics. Why important? Why it is important, electrical characteristics? Why? Because it provides typical operating conditions and performance metrics, right? So what should be the temperature? What should be the room temperature? And what particular temperature it works properly? All the details will be provided into this. So these are the second important point. This one is the second important point. Third important point is pin configuration and pin out, right? So how many pins are there? Since you can see on the screen on this, I've given one MOSFET. Okay, so MOSFET has 3 points, right? So please remember, MOSFET has 3 points, but we should not correlate it with the points of a transistor, like emitter-based collector. Here you have gate, drain, source. So all this configuration, all pinouts are given into this one in your data sheet. Right, now we'll go to the next sheet. That is, we'll see what are the next important points. Packaging detail and dimensions. Why it is important? It helps in PCB designing and physical compatibility with the circuits, including packages. What type of package it is, how many pins are there, what are the pitches of the pin, height, width, everything will be given in this. DIP pin or SMD. SMD means surface mounted device. DIP is dual inline. That means pins are inserted inside the holes. Okay. So all this information will be coming from the package detail. The next one is functional description. This is very important. Why? Because if you don't know what is the function of that particular IC, whether it will support your circuit or not, then it will be a problem for you. So feature of a microcontroller, just imagine we are taking a microcontroller or operational amplifier. So you should know what is the function, what is the role in that particular circuit. So that function description is very, very important. Then finally, the last point is typical application. Why important? Suggest common uses of component, help verify its suitability. Example, power regulator, switches, signal amplifier. Okay. Typical application. Why we use application? Why? Because it will tell you what exactly current rating, maximum, minimum, and what is the function of regulation, what should be the input voltage and output voltage. All these things, suppose it's a regulator. Suppose it is a switching transistor or something related to signals, then it will give you the complete detail about that. So these are the few points I have just shown you, which you have to keep it in mind. You don't have to go through the complete details about these things. I have given few of the two just to show you. One is RP2040 on the left hand side. On right hand side, it is a microcontroller that is Atmega 328P microcontroller. Both of the microcontroller are important. In the coming future, we'll discuss about this. The RP2040 is Raspberry Pi Pico microcontroller, and Atmega 328 is used in Arduino. Right? Both of them are microcontrollers. I hope you understood this particular point. Thank you.
If you found this helpful, give it a thumbs up and subscribe for more electronics tips. Catch you in the next video. Cheers!